Well, welcome to Sarah in Tech. I'm Sarah, and today I'm going to be interviewing Mr. Nathan Bott. Did I say that correct?
Nathan
Bott.
Yes.
Yes. Who is a senior solutions architect, correct?
That's right.
For the company Red Hat.
Red Hat software.
And so every time someone says Red Hat, I think of like Linux and stuff
That's right.
like that. Okay,
Yeah.
good.
Yeah,
I'm a data scientist.
We're data scientists, right? We're known for being kind of the, probably the largest open source software and services company in the world. So we kind of take open source software and productize it and allow our customers to subscribe to it.
I mean, I've had access to like a Linux machine since
Right?
I was about 10 because my dad was like, this is open source. You need to learn how to use it. So I definitely have been familiarized with it from a young age. I'm not sure many people get that opportunity.
Yeah, that's right. I do the same thing for my children. It's like, learn Linux and you'll be fine.
If you can learn Linux, you can do Windows and Mac. Not a big deal.
Right.
So why don't we start out with you were born and now you're a senior solutions architect. When did you discover your passion for technology? Kind
of by accident. So, I mean, if you take out the formative years in high school, I found myself in college, or 1990, 91, and I was in school for pre-law and for history and poli-sci. And I realized about my third year in that, I didn't want to become a lawyer because there seemed to be a lot of lawyers and all the people I knew that were going to law school seemed pretty miserable. So I kind of stopped what I was doing and I joined the Navy. So
wow, that was a pivot.
Right, exactly. And not only did I join the Navy, I was able to test out and kind of always had a science background. My father is a chemist and biologist, so I always had science in my house. But I guess I had a pretty high acuity for chemistry and physics and math. So I tested out and got into the Naval Nuclear Program and kind of went head in vocationally into naval nuclear power and the power school and went through electronics technicians and school and mechanical and electrical and became a reactor operator of all things. So by the time I was 22, I was qualified on 2 different reactor systems, one on a sub and one on an aircraft carrier. And so I liked engineering. So went through that for 6 years and got out and thought I was going to go into commercial nuclear power. Went back to school at Old Dominion doing engineering and engineering technology and management but came out and decided not to do it because I didn't want to work in commercial nuclear power. When I realized what they did, it's a great industry, I think, in a lot of different ways, especially now in the revival of it. But it's pretty tough work in terms of working rotating shifts and it wasn't really conducive to having. I got out of the Navy because I was going to have a family, so it didn't make sense. So I decided to I sent my resume and my background to an IT web hosting company in Boca Raton, Florida. I was living down there at the time, and they brought me on as a inventory specialist. So it was actually one of the first web hosting companies in the world called Highway Technologies. It was located in a building where IBM was, where Bill Gates worked when he was with IBM in Boca Raton. And so I kind of learned from the ground up about web hosting. And at the time, they were using Linux and also using I guess it was IRIX Origin 2000 boxes for their web hosting. So I kind of, like I said, from the ground up, learned that and kind of progressed through being a systems administrator. But I wasn't into technology directly, just for the tech's sake. So I worked, like I said, like a systems administrator, and I'm working for Google in 2001, 2002.
Wow.
So I was one of the first 2 engineers data center engineers on the East Coast to be hired for Google when they were still in, co-located data centers. So myself and another gentleman, he just came out of college. We were, managing clusters, big Linux clusters for Google, and which is pretty good. But it was pretty arduous work, and as you can imagine, it's just 16, 18-hour days, 5 to 6 days a week, and it was pretty grueling. So I did that for a couple of years, and.
Did you have to do the on-call thing? And
yeah, you're on call. Well, it was great because I mean, it's redundant, right? So you don't have to necessarily fix it right away because there's so many other. There's so much redundancy built into a distributed system like they had back then and they have now. But as it happens, like I said, I wasn't in for the tech itself. I was always into technology, see what it does for the rest of the world, the rest of the working world. Mm-hmm. So I ended up working for a hospital then, and working as a systems analyst, and working with doctors and administrators and nurses and pharmacists, and spent a couple of years working for a small community hospital in Virginia, doing electronic medical record implementations in health information management systems. And that's where I really liked it, where I had a way to take technology, software and infrastructure, and actually get it to be used by clinical staff or administrative and operational staff, and being that technical consultant. So kind of as a systems analyst and consultant, as well as then becoming a project manager, started managing a lot of projects and became basically a healthcare project manager. And
what do you think really led to your ability to project manage? Because not a lot of technical people can make that transition, and you've made how many career transitions? Keep pivoting, and I'm like, surprise ending. I'm actually ruler of the world.
No, well, I guess it's because I truly like working with people. I mean, there was a time where, I think a lot of folks that are young that take on technology and they kind of get all this knowledge and they understand this stuff, and it's kind of cool. And sometimes you can get a little full of yourself, and you're like, oh, they don't know this, they don't know. But I really enjoy teaching. Why does this work this way? Why isn't it working, right? Usually you're helping them fix a problem, and then you could try to educate them and get more comfortable with technology and computers, especially in healthcare at that time. So this is 2005 through 2008, when you have a lot of folks that are going from standard paper processes to more computer-driven workflow. And so I just loved working with people and seeing them kind of adopt it and get more comfortable with it and start sharing their knowledge of it. And getting people to adopt technology, because it's still actually an issue right now in a lot of businesses and enterprises. It's really adoption. You can sell all the best software in the world, all the best product and technology, but unless you get people to use it, it's kind of worthless. And so that's what I keep on doing. So and I enjoy it. So I guess I should carry on. Well. After doing a project management, and I ran a couple of projects, so I was with a small hospital system and then went to a larger hospital system and did larger projects. I got pulled into pre-sales. So in my infrastructure time, I learned a lot about storage and in data center operations. Well, EMC was looking for some pre-sale solutions architects or systems engineers in the Washington, D.C. area, and for their healthcare district. So I could take my healthcare experience and then my old infrastructure experience and try to get it to come together to help EMC, with their customers, come up with better data storage and data management solutions, especially when all the hospitals were kind of consolidating and there was a lot of infrastructure homogenization. So they needed a lot of help in that way. So I was working there for a while, but then, being in DC for almost 13 years and being on the Beltway and I wanted to move away from that.
The traffic.
And move out
Did your
west.
kids go to the school system there?
No, we're a little bit, we're in the Shenandoah Valley of Virginia.
Okay.
So we're about 60 miles away. So I was commuting an hour in, and then I had the Beltway traffic. So after doing that for many years, I was kind of tired of it. And then I wanted to move west. So I wanted to go to Boise. So I picked Boise. This is in 2013.
Before it was cool, you picked Boise.
Yes. Well, honestly, because we really couldn't afford to live anywhere else in the West. It was the best place for a large family to move to.
The ultimate irony.
Yes, exactly. It is. It's lamentable now. And St. Luke's actually hired me as a contractor, as a consultant project manager. It was a fixed term contract. They had some projects that needed to get done. And so I got moved out here and worked for them for the first year and a half. And then I went back to pre-sales because I could stay in Boise. I was done my projects, and EMC hired me back to be a global solutions architect. So, working with EMC and then Dell, and now I'm with Red Hat. These are enterprise kind of infrastructure software companies. I'm doing what I do best. I'm working with people directly, customers directly, and positioning product portfolios to enterprise strategies, and then helping the sales guys meet their quotas.
So a lot of pre-sales work.
Yes.
What skills would you say are necessary for your role? If someone was like, I want to be exactly like you, what would you tell them to go out and do? Go talk to other people, learn to be social.
You know what's great about pre-sales, and a lot of my colleagues would say this, is there's so many people from different areas. We have a guy that just came on our team. He came from law enforcement. We have people who have been physicists, or you name it, any kind of background. Like, maybe, the first part of their career, they've done the work and they've kind of satisfied what they were looking to do. They became successful in it, and then they want to do something else. And a lot of those people, just because of their experience and being able to solve problems in different domains and being personable, and they make great pre-sales architects, because it's taking the business side of it, it's taking the technical side of it, it's taking how do you deliver it, how you manage it, how do you support it, all into one ball, and being that really primary contact person for the customer back to the company. So I'm really a customer's advocate is the way I look at it. And I do my best for my customers so they get the best out of that product that they purchased, and it's useful, and it makes their job easier. And ultimately, at the end of the day, that's what I want them to do, is be able not to be so overburdened. Let's automate where we can. Let's bring in new technologies that make it a little bit more efficient for you to sustain application development and deployment and so forth.
So having like a diverse skill set and being able to talk about the technology and how it's applicable to them.
It's always about value proposition, right? I mean, it's not about, the technology in itself is fascinating, and there's so many things you can do, and if that's your career path. But if you really want to go ahead and get to the, and make it usable and valuable to CIOs and CTOs and even business people, not just IT, but also business, and kind of they see why they should invest in their people to adopt the technology that we're providing to make their business easier to run. So that's my end game here is, and the thing is, you can't just settle on one technology area or domain. You have to know so much, because there's so much that's going on so fast.
I know that I hear that there is a need for project managers, and a lot in that space. There's a lack of PMs, and there's no actual degree that gets you to be a PM, because as you were saying, you have to have a diverse background and be able to talk to a lot of different levels of technical knowledge, as well as different domains and verticals. And so, I mean, it's just a space where we need more people who are able to be in it. I know I've definitely been on projects where I was like, gosh, we could really use a PM, and a lead data scientist isn't cutting it as much as I try to. You need someone that does that.
Yeah, good facilitators. I mean, I would say educators, even educators that maybe taught English, or they're really good facilitators. They're good communicators, and that's what you really need, is to be able to communicate and actually listen to what people are saying, and then contextualize. I mean, where project manager skills came in handy in healthcare in particular was you would talk to doctors, you would talk to nurses, you would talk to pharmacists, and they all have different incentives. They all have different problems they're trying to solve, and they want to work together. And that was actually one of the most edifying things, is to be able to get those stakeholders together and get them all on the same page and agree upon a path to a solution that's using technology. And if you're that kind of person that likes to see that type of collaboration and working together and have those aha moments, then that's a great career for those folks. But a lot of times, a lot of customers are dissatisfied and it could be, you could have a great project, but this little 10% of it wasn't that great. That's going to be amplified, and sometimes you have to kind of work through that. And again, that's the other thing too, is objection handling. How do you handle objections? How do you convince a person to see the other side of it, and then also address the objection that they're bringing up.
I mean, we all know that every software has some drawbacks.
Yes,
and it has some strong suits. And so working through that with the customer, being like, yes, we know there are drawbacks within this specific area, is always something that you just have to deal with. I know different technology stacks, if you will, some of them are better at real time, but then trying to put a machine learning algorithm in there, it doesn't always work as well. But real time graphing is better in different environments, and so on and so forth. Right. I guess I know data science speak a lot better than general computer science speak.
Now that's with Z Data, for instance, it was great to work with such a diverse set of technologists, right? You had your DevOps folks, you had your developers, you had the data scientists, and then trying to kind of glean what they're really good at and what they can bring to the table for a certain project and deliver value to the customer. I thought that was kind of interesting. Just and it's sometimes it's work. It's always about trying to convert what one person's saying or doing and what it really means practically and operationalize it. So it's always an interesting world to live in.
Have you heard about the recent technology that GitHub came out with, where you like put in some plain text and then it starts building the code.
Oh, wow. So it's
you.
actually like a deep learning, little capability. Yeah.
Yeah. Made a few coders a little nervous around the collar because, then anyone can just go in and be like, I would like a program that does this. Cool. Thanks. And
interesting.
It runs off and it creates the code. Someone said it's really good at boilerplate. I haven't tried to use it yet. But, simplifying the coder's job, if you will.
Right. Well, I mean, these things take time. I mean, I remember, what was it, over 10 years ago, maybe 15, we're working with ambulatory care, providers that were trying to use, Dragon Naturally Speaking to do, voice to text for their EMRs. And it was a mess, right? And even still, it's not perfect, right? Because you still have accents, you still have, context.
Mm-hmm.
I remember there was a whole, push to get transcriptionists, out of the hospital, out of the place, because it was all going to be done with either front end or back end speech recognition. And I'm sure to this day they still have transcriptions because, they're much more efficient than they were to say 10 or 15 years ago. But you still need that person there to help out, and technology is not always perfect.
I mean, I recently became specialized in this area. I'm not a transcriptionist, but I'm very familiar with kind of like the transformers and the lambda nets that you use in that space to do the voice to text. And then you have a transcriptor look at the script versus the actual audio file.
Mm-hmm.
There's a company that does this better than a lot of places in Silicon Valley called Rev. Have you heard of them?
No.
They can do it better than, my little Google Dot or Siri or Cortana, if you will. And so they're really good at voice to text. It's kind of mind-boggling how good they are. Right.
But we're still talking about it, 15 when there was still technology, trying to be implemented, practically, that long ago. So it does take some time. But then that's enough time for people to find other things to do. And I guess you could sit there and be afraid that you're going to lose your job or figure out, okay, how can I be of value in an organization? Mm-hmm. And I think a lot of organizations, so I've worked with healthcare, state, local, federal, and I always get the sense that those organizations are always trying to look to enable their employees and their folks, and though the automation's coming down the line, just try to, let's figure out how we can work around that and use it as a tool as it is, as opposed to being afraid of it.
I mean, I've heard doctors express that they are afraid of artificial intelligence,
mm-hmm.
Because they also on their side Google symptoms to say what is your ailment, and so a computer possibly could take that space a lot better than they could. And so I know someone who might be the head at a hospital system for artificial intelligence, but he is not allowed to use the words artificial intelligence in describing what he does.
Well, I in my career there, with what I just went through, I worked with a small startup called Autocode, and it was founded by a guy named Don Rosenthal, and he took some of his artificial intelligence algorithm basically from the Hubble telescope. So he was focused on stochastic optimization and schedule repair.
Mm-hmm.
So he was able to do it with the Hubble telescope. So he ported it first to manufacturing for lean manufacturing to do schedule repair, and then he did it to healthcare, in particular radiology or procedure-based environments, to be able to go ahead and get higher utilization of investments in CTs and MRIs and X-rays and ultrasound and so forth. So I was kind of, I worked for this small startup, implementing it as a workflow consultant and project manager. And, some of the hospital systems were, just embraced it and really worked well for children's hospitals because, they're complex workflows because the children usually have to be sedated before they're put into an MRI. So you have the anesthesiologist, you got more nurses, you got the medical techs, and then you have, the radiologist that's doing the procedure. And so this software worked really well and be able to manage all those pieces. So then you can get the most efficient, procedure done. And so, but the thing is that there were some folks, especially on the nurses' side, some of the technologists were really, really apprehensive because it was considered AI-enabled, scheduling. And they thought, they used to have big whiteboards and they'd have their outpatient schedule, inpatient schedule, what was going on and what was down, what was up. And we were able to do this with this application called OnQ. And it was fantastic. And a lot of doctors loved it because they just saw the value of it and being able, because then you could figure out whether or not you need to spend more capital getting another CT, or could you send them across the street because we acquired this facility and they got extra CTs that we can use and get them over, and also get the backlog because everyone complains about how long it takes to get the radiology procedure done. So it was great. But again, this is like 10 years ago, there was so much apprehension against the word artificial intelligence. And, so it'll keep on, I think, going that way until like everybody's either not employed anymore or embrace it as their own tool, right?
I mean, computer science has been around since 1970. I don't think it's going away
just
because someone, made a text to code, and now websites, it's just text, and then a website exists, and these things are going to be easier, and then your time, programmers' times can be spent actually doing fun and interesting problems rather than designing another website or doing something unique in a website environment.
Exactly.
Yeah. I think you mentioned something while we were speaking earlier about how you never had access to video games, and so you felt like an outsider in the computer science culture or the IT.
I was a very unlikely technologist. This is where I really am, in terms of how I see myself, because I grew up without any, we had the one TV with the 3 channels. I grew up in the 80s, but I was like out in the boons of Pennsylvania, and I never had video games really, or even cable. So in order for me to get any kind of like say entertainment that way, I'd have to go to like a relative's house, a cousin's house, and play it. But I really didn't play video games until I was probably first or second year in college. And I don't think I even used a PC until I used a PC while I was in the Navy because I was injured. So I played a lot of sports when I was a kid. I fished a lot. It was like, I was outside a lot. A lot of boring summers, figure out how to entertain myself. Was incentives to save up money and buy a bike so I could ride my bike to my friend's house. But it wasn't really until I was in my mid to late 20s that I started in anything with IT. So I would say I think my wife was the one who set up her Packard Bell that she had from college, and I was learning Microsoft Windows then. But my first operating system I did learn was Linux, because I was working on a DNS project at this Highway Technologies that then became Vario, and we were rebuilding or homogenizing a whole bunch of DNSs on Bind, and that's kind of how I learned it. But I was probably 27, 28 years old at the time, so nothing technical growing up at all. So I can tell, I could hear all the old timers talking about all these different chip architectures and different mainframes or different Spark systems, and I kind of know the history of it, of course, and I understand at a theoretical level what the differences are, but I never actually lived it in a sense of working on it. So and that's so I always appreciate those guys that do it, but I said I was just the guy who went fishing and threw a rubber baseball against the wall and caught it.
Well, I mean, like, that's really interesting that you haven't or didn't have access to like a computer growing up, but you're still terribly interested in technology and you use it regularly in your day-to-day life now. Most people in that setting probably wouldn't have taken to technology. I know people my age that don't like computers, even though they are forced to work with it. So it's very impressive, actually. That's what I'm trying to say.
Oh, thanks. I'm
trying to give you a compliment.
Oh, thank you very much. Yeah, I mean, it is. I guess I'm genuinely interested in understanding how working, and the engineers that we work with, that I worked with at Autocode Data, that I work with Red Hat, with Dell EMC. It's just fascinating, just the level of technical, abilities they have and be able to solve problems at that. So I always have appreciation for that. But I just like science and technology in general. So especially when you get to merge them together. So the folks that are doing, the stuff in biotech and things like that is just fascinating.
Have you heard about how they can take computer programming and sequence it into DNA?
No,
They can. They can synthetically do it with a 3D printer, so they can create DNA based on.
Okay.
And so then the question becomes: Are we just computer programs walking around waiting to be deconstructed into some program? Here, let me give your DNA. You have the perfect program to organize the inventory, if you will.
Right. Oh, that's interesting. Yeah, I imagine that's satisfying a lot of the theorists out there that think we are just a simulation of sorts.
I mean, I guess you could look at that. Then becomes the question is, do you think you have a choice and can change your outcome, or everything's predefined?
Yeah, that's the free will discussion now, isn't it?
Yeah.
So yeah, it is an interesting discussion because I think I tend to be more on the free will compatibilist kind of. I can understand where there's some things that you can't control and we do without our known cognition of it, and then there's obviously things that we do that we know we're doing. So, but then again, I'm just simple technologist trying to fix enterprise problems.
I mean, there's even like a genetic marker that will associate with whether or not you're the type of person to move more than 20 miles away from like where you grew up.
Oh, interesting. Okay.
Yeah.
I wouldn't be surprised about since some of that stuff because people do have those inclinations. I mean, that's it's an interesting thought because my wife is Irish, right? But her father was like the only person in her family that ever left like the farm in Ireland. Mm-hmm. So they all still live there, and they all live like 20 miles away, or I think it's 20 kilometers actually.
Gotta switch units.
From this farm in Ireland, and it's just amazing that that's a lot of that family. But her father was the one out of 6 that decided to come to America, and we were like one of the first Americans, for them to meet when we went back. So it was pretty cool.
How many times have you gone back to meet her family?
Just once. So she actually grew up in London, but
oh wow,
but it moved from Ireland to London, and then came over to the United States when she was a teenager. But we were supposed to go back last year in 2020.
Oh no!
So we're probably going to go back next summer. So that's we're waiting to see how this thing pans out.
The Delta variant,
yes.
The Echo variant. I'm sure we'll keep going until we get to the Omega. At this rate.
Right. Yeah. So it'll be interesting. Hopefully we can get back there and visit. But like I said, I always found that fascinating. Actually, a lot of folks that I grew up with too in Pennsylvania, they stayed very close to where they grew up. But so there's some of us that leave and go explore the world, I guess.
I mean, I also did that. I'm nowhere near where I grew up.
Yeah.
So that's why I guess I brought it up. Not because I was trying to genetically target you for your marker. I'm actually from Detroit, Michigan. You can tell.
Yes.
The way that I look.
Right.
Very rugged.
That's a hotbed of engineers because of the automotive industry. So I mean, it's a lot of brilliant engineers and automotive folks there. So I mean, there's a guy I know in Micron who's a PhD and does process engineering and chemist, and I think he grew up outside of Detroit and in Michigan, and his father was in the automotive industry, and it's pretty awesome.
Yeah, my grandpa, but it has some of the best public schools in the United States. Actually.
Yeah, I would imagine so. Right.
Even the economy still is kind of not that great yet. Yeah. It hasn't bounced back.
What I loved about Michigan is that living in Virginia, there's a lot of folks from Michigan that had moved. I guess get tired of the weather. the gray skies and the snow, but a lot of them came from farms, and they were just like solid folks. I mean, in terms of being able to do anything. I mean, from where they were doing computer programming, and then they're also building tables in barns. And I was just like, I was always so impressed and just like almost jealous. Like, man, they've so because it was just like they had to do it. They weren't going to buy it. They weren't shipping it from Amazon. They were actually doing it themselves, and it was pretty astounding to see folks like that. And I you see that a lot in Pennsylvania, but also Michigan.
I mean, everyone says I'm a handy woman because I just whip out a tool bag and start fixing things. I love doing DIY projects in the house.
Right.
And I'm like, I also like programming, but let's paint this wall.
Right. That's I think that's a great character of kind of the down to earth and salt of the earth folks from the Midwest.
Yeah, I guess that is a Midwest. Even it's considered Eastern time zone.
Yeah.
So technically, in some ways, they behave, I guess, like East Coasters. Supposedly, okay. Someone said at some point.
I see.
Anyway, what is some life advice that you think would stand the test of time, or something that you would want to tell your grandkids that you don't have yet?
I do have a grandkid.
Oh, sorry.
That's
right. You do have. Sorry. What is some life advice you do want to tell your grandkids?
No, or my kids. Yeah, I mean It's a good question. One thing that I realize or I see a lot is this, don't necessarily get trapped by the pursuit of knowledge in itself. A lot of knowledge is kind of inert, and it's kind of cool to find out a lot of information. Like everybody's a Wikipedia expert, right? All kinds of information about and quoting this and knowing this. But what I would say is focus on methodology and processes and tools to solve problems. Because everything that you and I are doing today will not be done 20 years from now. There's going to be something new, different, totally something we will never be able to anticipate. And you want to be able to be, you want your kids to be able to do that. So not to get hunkered down in one thing and just know it. I mean, it's good. I think it's good to, like you want to learn a foreign language, probably pick up, if you're going to work in technology, pick up some language and understand the structure and framework of programming and understanding syntax and logic and things like that. And then of course, math, but also other things, just, finding patterns in different domains that you can apply when you're trying to solve problems. I think that's something I would tell my kids. And, I'd probably tell them to probably be a little bit more focused than I am and not get bored too easily. But, it's worked to my advantage. I don't know whether it'll work to my father laments. My father was a food scientist and worked for a same company for like 30 years and always gives me grief because, it's like, why are you doing this different? Like, why did you change? And I said, this is the way, I am. And I think it's the way the world is. And
I mean, I think it's a very common thing to not be loyal to one employer anymore for 30 years. That's a very common thing.
Right.
Nowadays.
Exactly.
I honestly can't say I know anyone that has left college and stayed at the same company since college. And I graduated, a little bit more than a decade ago. It's just, that's the way it is. It doesn't pay to be loyal to an employer anymore.
Yeah, I mean, that's one thing that's refreshing about Red Hat. There's a lot of folks that have been there for a long time since the beginning because, once it became a company in the 1990s. So my current manager's been there for 16 years.
Oh, wow.
A lot of the leadership. I saw that at Dell as well. Not so much, kind of we'll say legacy without getting legacy, technology companies. There's a lot of folks that have been there for a long time. And I think it's good to have those folks for that institutional knowledge and continuity with the customers in particular. But you do see as employees get younger and younger, they are going through. And I used to say it was more project based. It was always about solving a problem or working on a project and getting it done and going to the next one. And and I think it's great to do that when you're young, to be able to go from one thing to another, try to solve different problems, work with different people. I think that actually helps out in terms of encountering the change that's always going to be there. If you're working with the same people and the same thing over and over again, there probably is going to be a complacency that sets in, and that can catch you off guard when things do change. So,
and I mean, change is inevitable. It will happen.
Yeah, it's supposed to happen. Really, I mean, I can't. That's where we all are, and navigating that and figuring out a path. For your own career path, helping out other people, helping out your customers, navigate that as well. So,
have you ever mentored anyone?
I would say yes. I've mentored folks. I was thinking about that question because I've never had a mentor, like, a long-term mentor. I've never been a long-term mentor, but I've been on teams where we were cross-functional. And I thought about this. First hospital I worked on a clinical systems analyst team. So half of us were like IT technologists, but the other half were like nurses. So, I worked for a nurse who was a cardiology nurse. And then one of my colleagues was a OBGYN nurse, and she worked in labor and delivery, and then med surg. So what was great was we kind of mentored each other and are in understanding how to deliver technology to clinical operations. And I always thought that that particular manager, she was just a great mentor, and it was like, to me, that was like actually my first real manager. Like, and she knew how to manage not just us IT people, but also doctors and other nurses and administrators. So she had a gravitas to her, and I always took that is that she was very, before she made a decision, she went through her paces to make sure it was the right decision. It was the right decision for all the stakeholders. So we always kind of mentored each other, and then from a technology side, we taught the nurses a lot of things about systems thinking, because you think in nursing and in healthcare, there's biology systems thinking, and then there's systems thinking, and they're quite different when you're talking about sustaining operations and managing those electronic systems that doctors and clinicians use. So I always thought that, but in terms of mentoring other folks, it's always been senior, junior level. As a project manager, you do that a lot.
Yeah.
Yeah. So it's kind of part and parcel of the position.
I mean, I definitely have learned a lot from the project managers that I've been with, and they started to teach me some project management. So that's always fun to do and learn about other people's roles.
Yeah, so that's, I've heard of, and I have a mentor right now actually within Red Hat, and he's great. So he's kind of helping me navigate and find the information that I need as fast as possible.
That's always challenging when you're newer at a company that has a lot of legacy knowledge.
Yes. And
who do you go to ask this question to get this thing to go to the next step?
And everybody needs that. So
yes.
I think that's it. And I think it's very, very important especially with the amount of change of people that are influxed, that you have some continuity there.
Mm-hmm.
So,
is there anyone that you really follow online to keep up to date?
Well, I totally got off Twitter last year, and so I don't follow anybody anymore. I do follow some blogs, I would say, but it's I like I said, I'm more interested. So I've always been interested in kind of Timothy O'Reilly, what he does. I don't know if you know Tim O'Reilly, the O'Reilly books.
I mean, I've heard of the O'Reilly books.
Yes,
I think if you're in tech and you haven't heard of the O'Reilly books, you're in trouble.
So actually, I know two of his brothers. I used to live right by them in Virginia.
Oh, wow.
So and he's out of California. So and I always liked what he did in terms of knowledge, sharing. I know so he's always been an advocate of open source, and his books kind of speak to that and sharing of knowledge. And so he's got a lot of good staff that write about technology trends. So I always kind of follow that group, I'll say. So and just like anything else, there's no one in particular that I follow. I think on Twitter, I probably follow comedians more just to get a good laugh.
I mean, especially with the last year and a half that everyone has had, we all just need a good laugh.
I just didn't want the, politics seems to seep into everything. So, but I did, I guess there's one political geo guy. I think his name is Ian Bremmer. He's kind of interesting. Talks about global security, and not only physical security but also cybersecurity. I thought was interesting. And the effects of globalization and economic homogenization, and how that fed into the last couple of years. So that was one guy I thought was pretty interesting. But usually I kind of I'll read. I like podcasts. So I like science podcasts as well as sports podcasts. So.
Do you have any what's your favorite, or what's some of the ones you listen to?
Probably Sean Carroll, Mindscape. I think he's got the best one out there. He's one of the best interviewers, and he's got such a variety of folks that he interviews, and across all domains of science and technology. So I really appreciate what he's done. He's a great science communicator. So and is I think pretty important when you want to learn about he does both philosophy and actual pure physics as well as other domains of science. So I enjoy him.
That's very cool. I'll have to check him out.
Yes. I usually do tell people about him and say he's worth a listen to, and he's really a cosmologist at Cal Polytech. But probably if you haven't heard of him, he's one of probably the best science communicators out there.
Well, sounds like it.
Yeah.
Especially if you're speaking that well of him. So do you have a favorite programming language, or are you just do you program anymore?
I do not program. That was one of the things when I first got into IT, I was trying to figure out, I didn't realize there were so many paths you could follow. So, you had the kind of traditional systems admin, data center technician, the networking guy, a programmer. And so when I worked for Highway Technologies Vario, I went to one of the lead programmers, and I think his name was Matthew. And I asked him, I said, so I want to learn, I want to learn about IT, I want to learn about application development. if you had any suggestion, what would you do? Like what school, which courses? And of course, him being in that position, he's been like programming since he was like 10 or 12. And he wrote a program and sold it with his grandfather, who was like a real estate agent. And I was just like, oh, okay, so I'm really behind the ball. I'm like he's been doing it since he was 12. He's probably in his mid 20s, about the same age I was. I was a little older than him. I was like, okay, I see. So maybe that's not my place to be. Fast forward after learning, compute and storage and networking as a system admin, and I was working on a master's degree, and I had to take programming. So I took Java and data structures, and kind of persevered through those, we'll say. And not that I couldn't do it, and I did do it, but it just was not something that I fully enjoyed. It took a lot of time. It's tedious. So I always have an appreciation for folks that have, like I said about focus, who could focus for many hours on one particular problem and going through. So I did it, and I passed, and I said, you know what? I'm glad I did this. I can move on to other things. But my wife laughs at me because I still have my Java book, which was it was an Oracle book, but I also do have a Python, basically a Python book. And I got all these courses that I sometimes take around, Python and data science, because sometimes I'm reading or I'm listening to a customer and concepts come up and I go, well, I want to know what that actually means. So I can go, I may not apply it, but at least it provides me context. And I always think it's helpful to have that framework. Like I said, we all had to take Spanish or some other foreign language. In high school, we probably should do it. So then at least you have a good model in your mind of what these things are and how they're applied, and so you're kind of fumbling with the concepts.
Or at least the structure of Spanish is different than that of English, and that was really revolutionizing to me. It was like, you don't just literally translate the word for word. It's the same formula of hi, my name is, it's not the exact way that it works in other languages. They order the sentences different. And so,
right.
I mean, even just at that granular of a level, as someone who's working in that space, it's just, having an idea of how it works. Right.
So it's actually doubly complicated for you because you got language processing and then you're actually software development languages, and then that's pretty cool.
But I was just liking programming languages to the actual human language as well. So
right.
I took a different path to get there, and I've never actually taken a programming class.
Yeah.
So I can totally relate to you, and I've never intended to be a programmer. I just liked math, and this has all just been a mass pursuit of math, and somehow I've ended up here. So
what are the key principles of math that you're using within? I understand.
I've kind of gotten lost along the way. You go down this little path. You're like, I love math, and then I don't derive anything anymore, or integrate anything anymore. But technically, at the root of a linear regression, you are doing. You have to optimize for the coefficients.
Right.
Understanding that space, but this has just been I got sidetracked from my original pursuit of math, and now I'm somehow programming.
Oh, interesting. Yeah, I guess that's. With data science, because there's, I think data science, there's a lot of folks from different backgrounds that kind of find their way into that area. Because data science, imagine having specific domain knowledge is so important to be able to contextualize the data in which you're trying to, glean those insights from. So, that's the, I think, we work together with predictive maintenance. Mm-hmm. So, last summer, while I was there, I took a course on smart manufacturing from MIT. They have these great professional education courses, and it was really applying, machine learning mm-hmm. and going through, manufacturing, smart manufacturing, with IoT and sensors and doing math and actually taking almost like a, very basic 3D printer, extruder, and then coming up with a way to model it, so to make almost a digital twin, and being able to predict, based upon the speed of of the spooler, how thin or thick is the fiber going to be, and things like that. So it was actually a nice application, and that's what I mean is that is that sometimes you get into areas, and like I said, I'm a technologist, a project manager, but I really want to know what are some ways to approach the problem. And, I may have that Python book, but there's so much stuff, whether it's in Udemy or MIT or, edX or whatever. You can learn so much on the fly that, really, the world is ours. And compared to what it was even when I was in college, it is astounding. So,
But there are some places that still, they want that degree. They want the letters at the end of their name, even though most of the knowledge is very free. And, they give you a little Udemy or whatever certification.
Yeah.
And you might even know more than practical knowledge than a PhD, but they still want that university stamp on your forehead.
Yeah, I imagine so. That's, there's, I guess, a bit of tribalism there.
Yeah. Well, I knew someone who would only hire U of I graduates and they wouldn't hire BSU graduates. And
really? Okay.
Yeah. So, no matter how, polished the BSU graduate was, they wouldn't hire them over a U of I graduate. And I was like, oh, I didn't know people were actually like that. I thought that was just, a myth.
No, yeah. People have their biases and their thoughts of, and probably is more the case, I don't know about now, but obviously your example, but I don't see it as much, at least it hasn't affected me as much. But then again, people who work at certain companies, they can kind of get access to other companies because they have other people there. Mm-hmm. So unless you've worked in a certain industry with a certain company, a certain group, you may not be let into that other company. So it's there at different levels, I'm sure.
Yeah, I'm kind of surprised sometimes the stuff I run into, right. But it's whatever. It's life.
Yeah, it is. It's the things you figure out how to navigate around and kind of prove your worth. Other than now, and I think in a lot of cases those degrees are pretty valuable and well worth it. But but then other folks don't have those opportunities, whether it's life circumstances or money, and that's kind of how I was. I'm autodidact. I never got formally educated in IT. Everything's been self-taught, or I take the little classes. But I think the methodologies and the problem-solving approaches that engineering teaches you generally has been very helpful.
Learning the scientific method in general probably was very helpful, applying it constantly
right, exactly.
to what you're doing.
Exactly.
It's been helpful.
So I also like the engineering management part of it, which was pretty important because, you had the economics part of it and the statistics and operational management and project management. Because again, it's not just about the technologies itself. It's like, how do you make this useful? And I did, and we talk about mentors. My engineering management instructor was this woman who worked at NASA, and she was at NASA for 30 years, managed 5 different groups, in all the different areas that NASA has, and I forget what they are off the top of my head, of course. But she was absolutely brilliant, and she was so funny because she would say, she'd get a new recruit of engineers in. And these are brilliant people, mostly men, right? And she would say they were so competitive because they've been competitive all their life. And she would say it would take her 6 months to basically break down all their bad habits, while keeping their engineering knowledge, right? And mechanical engineers, electrical engineers, aeronautic engineers, what have you. Because they all had to work together. They all had to work together to solve problems, be able to support this space shuttle mission at the time. Mm-hmm. But she said it took them 6 months because they were so competitive that you couldn't get them to work together. And and because they had their own domain biases, like the electrical engineers didn't think the computer scientists were good because they thought they were all dropouts.
What?
No, mind you, this is this is in the 80s and 90s that
computer scientists are dropouts.
Yeah, right. No, it's true. There's a lot of at the time. It may not be the case, but there was this notion that if you couldn't cut it in electrical engineering, even computer engineering, right, when you're getting into high levels calculus, that you would go ahead and say, okay, I'm not going to do it. I'm going to go do computer science instead. So it may not be the case now, but this is but back then. And then so she would talk about 6 months to get these folks broken down to be able to work together. And she said that was actually, it was very interesting, that things that she had to do to get them to be able, little projects for 3 of them, and then get 5 of them, so then they could understand each other's the trade-offs. There's always the trade-offs across the different domains. So I thought that was actually that was a great course that I took at Old Dominion University, and it was very helpful, especially as a project manager when you have different disciplines. And I was working for healthcare at the time when I was going through that. So
that reminds me of a personal story because I'm a data scientist, so I do math and I do science really well, and I wasn't such a computer scientist. So I was in a room full of programmers, and someone said something about packet speed. I was like, okay, can you explain a packet to me? And they all like turned their heads slowly and looked at me like, how do you know how to program? And I was like, well, I guess people could argue I don't, but I'm a data scientist. I know math. Do you know how to, implement a random forest and do it correctly?
Right.
Probably not as well as I do. So we all have our strengths and weaknesses. But no, it's a very common thing I run up against. But I know most data scientists are computer scientists, so they're probably not experiencing those types of things like asking stupid questions like, what is a packet? I know now. I promise, guys. Right.
It's true. I've been in those conversations.
Just like, please don't kill me. Thanks.
Right, and then you can go into data storage, right? And the network guys don't know about like SCSI,
I don't know about
or SAND or anything like that. So everybody's got their I think they're focused in their track. Mm-hmm. But it's great. I think she would take people out of their own groups and say, look, you're going to go work with the mechanical engineers and sink or swim.
I mean, I
figure it out.
I think that is everyone should experience some of that. Other
definitely.
people know a different chunk of the pie, and it takes a bunch of chunks of the pie to make a whole one.
Right. Well, that's the thing is it's integrated knowledge and being able to take different disciplines. And that was what was great about the Navy that I don't think I would have experienced anywhere else is that, though I was an electronics technician, right? It was really instrumentation and controls for the reactor plant. But I had to understand the mechanical systems. I had to understand the electrical systems. I had to understand the reactor physics. And it's actually the toughest part of actually getting qualified was they would give you integrated plant questions. So it would say, hey, what would happen if we turned off this particular pump for on the condensation loop in plant 2? What would be the effects of the whole on the whole ship as you're managing a reactor operating? And you got to go through kind of like, okay, what are my immediate actions? What do I expect in my readings from my gauges and readings, and then how would I react to that? And because you have to know the foundational, the theory behind the electrical system, the mechanical system, the physics and of the reactor and what's impacting that in terms of pressure and temperature, and then bring it all together to be able to keep the reactor in a safe space. So if you take that methodology of learning systems and integrating it, then applying it to different disciplines, I mean, it's really, really helpful, no matter what you're doing. So
I've actually worked with nukes too. So.
Yeah, you did at INL, right?
Yeah,
and that's fascinating work what they're doing over there. Yeah. So that's I loved working with those customers because you get to work with the enterprise and the HPC folks, and they're doing a lot of great work in terms of building out simulation of models of the new reactor designs. So.
Yeah, and there's a lot of different styles of reactors. Ones where they even take the plutonium and like they have like a scheme where they move the uranium to the center and then they slowly move it out from the center, and so you end up recycling the uranium and capturing the electrons again, or even encapsulating the uranium inside of concrete balls. That way all you have to do is take the whole concrete ball out, and it's a lot less a messy situation. It's
been messy in the past.
Yeah, the only problem is getting these like systems certified because they've been experimenting on them for
there's a lot of money now. I know that like NuScale out of Corvallis, they're doing a lot of work at INL. I think GE Hitachi, their small modular reactor systems are going through cert. So it'll take a while, but it looks promising, and I know there's a lot of excitement and a lot of investment into that area. Bill Gates has TerraPower, which is up in Washington, and again, they're going to more what's interesting is they're taking the technology that had been tested and actually researched back in the 60s and 70s, like at Oak Ridge, these molten salt reactor and
sodium reactors.
The sodium reactors, right? And now they're kind of refashioning them for usage, and then they're smaller and they have the microreactors. So I know there's a lot of thought of what the go-to-market for microreactors are, especially when you think about how fragile our critical infrastructure is on the electrical grid. If you can go ahead and get it more distributed and easier to solve, and then you have the other inputs from solar and other renewables, it's a pretty, that could be a way just to reconstitute what our electrical grid looks like in the future, instead of being like Texas last year. Right?
And that's not even the first time that's happened in Texas. Like, it happened 20 years ago. I mean, I remember looking at like an electrical grid when that was like a problem, and I had to write about it in a new reg document and stuff like that, and being like, why is Texas by itself in its own grid that all the other states aren't? Or just talking about how fragile everything is. I've looked at a lot of the alternative energy options, and I always wonder, why don't we go with geothermal? It's one of the few, like, there's nothing growing near it. We're not going to disturb anything, and it has a high energy output, whereas like solar has a drawback of like it creates toxic waste when you create it.
Right.
And when you decompose it, and
processor,
and as well as like even wind turbines, like animals get freaked out. So not super cool, but not super bad. Right. And nuclear obviously has like nuclear waste.
Yeah, there's a lot
kind
of
bad.
Too. It's all trade-offs.
So
it's very consistent and reliable.
And I mean, obviously fossil fuels aren't that great. And I mean, I worked in that space for the federal government for over 2 years, and thought about it a long time. And I was like, why don't we do more geothermal? And I mean, obviously hydro plants disrupt fish and all that. So that's not super good, not super bad, but geothermal, nothing lives at a geothermal vent really, other than like bacteria. No one's going to be too upset if we destroy bacteria.
Right.
Maybe.
No, it's a good question. I don't know enough about, I guess, the practicalities of actually getting it in what it looks like from a delivery standpoint. So it's I mean, like from a delivery standpoint, the way that you're characterizing it should be a slam dunk.
Well, I mean, I'm sure it's not actually a slam dunk, but like I just don't see the drawbacks, and I've like looked into it for quite some time, and I don't understand, other than the fact that we're not like we don't have a lot of geothermal vents would be the biggest problem. Yeah. But then Wyoming would be like the powerhouse with all their geothermal.
So we start a company called Caldera Power. We take all the thermal vents over there on the Wyoming-Idaho border, and all the hot springs that run through.
I mean,
between.
A few people might get upset when you destroy the hot springs, I guess, because they like hanging out in the hot water.
Yeah, that's true. I think what the Scandinavian countries would do well with that too, right?
Quite a bit.
Hawaii too, right? Yeah.
I mean, you can put it at the bottom of the ocean. It's not really going to disrupt anyone. I guess there's the tube worms at the bottom of the ocean probably wouldn't like it.
I'm sure there's advocates for tube worms.
We're joking, but I'm sure there actually are.
I'm sure there are.
Okay, we've gotten a little off topic.
Right.
What would you say is your favorite technology stack? Are you just not allowed to pick?
I guess I am allowed to pick. But
do you want to tell us?
I will keep the company. I do think there's, there's a lot of headway being made with Kubernetes and what I see in Red Hat and OpenShift. So, I would say that when you say technology stack, are you referring to specific, like a programming language and database and compute or a particular product?
I mean, we're just trying to get insight into your mind. If you said, Sarah, what's your favorite technology stack? I would say, well, so far I really like on-prem servers, and I like distributed databases. I'm not a big fan of Hadoop, but Greenplum was good to me.
I see.
And implementing models in there was pretty easy and straightforward.
Yeah. Well, I would say what I've seen personally from making a big impact is a lot of the automation around, whether it's Ansible. You've heard of Puppet and Chef, and now, there's so much, I think, focus on automating as much as possible. Now it's not just the infrastructure and whether it's the hardware or the operating system or even some basic applications, but it's automating everything up from what's on-prem, including the application, the app dev pipeline, to anything that's in cloud or on-prem. So between what Red Hat offers in Ansible, or even you have the free bits out there with Ansible, and then and then HashiCorp's Terraform, and I see so much adoption going on and so much work to go ahead and get that done because, frankly, a lot of my customers they can't find enough people, and they really are coming against hard stops on projects.
Just like explain it to me. What does Terraform exactly do?
Or we'll say what Ansible does. So Ansible is it's a platform that allows you to automate kind of your daily operational tasks. So whether that's standing up a server and configuring it with networking and an operating system and getting it running to actually put an application, it could be deploying an application, right? That means having to go through a DevOps pipeline and automating that and getting it deployed, whether it's in it could be for development process, testing, user acceptance, load testing. You can automate that. You can automate networking, right? So if you know that application has certain ports that need to be open and you need to secure it, you can automate that on the networking side. What you're seeing now is a lot of security operations. So you've heard of NOCs, right? So network operation centers. You have now you have these security operators or SOCs that they have all this different firewalls and intrusion detection systems and logging systems like Splunk or QRadar from IBM, and they need to take all this information and start correlating it, right? And so and be able to make and automate decisions. So you can automate based upon all the data that's coming in to go ahead and lock things down when they think there is an attack. So, but you could do it with one technology, but most places have a heterogeneous environment. So now you take as much, and so to be able to automate not only the collection of that, but then responding to it is becoming more and more important. So I think to me it's just taking off everywhere, and because it's become one of those things that's imperative by all chief executives, especially around security and around cybersecurity.
Oh yeah, cybersecurity is terribly important nowadays, unfortunately.
Yes. So and then in Terraform is similar, but it kind of focuses more on being able to stand up infrastructure in the cloud and be able to and automate deployments in the cloud. And so instead of using those native tools, so both like the Ansible and the Terraform stacks, they're kind of complementary and they work really well together because ultimately you can get very granular on what you want to deploy, and then what's nice about especially Ansible is that whether you're using the open source version of it or the Red Hat subscriptions, you have so much content that's provided by the communities. So you have certified content from all the different, like 90 to 100 different IT vendors, or literally thousands, tens of thousands of people have contributed their own code to be able to get content together to be able to automate. So you could stand this stuff up really quickly, and that's one thing about Red Hat it's really eye-opening. Is just how many folks are willing to contribute back to the work that they did to make the product better, to help other technologists be able to manage their their IT infrastructure and environments. And and Red Hat really does live this kind of open source ethos and being transparent and being collaborative. There's really nothing proprietary in their nature. Mm-hmm. It's so and the subscription really is meant for really just for support, knowledge management, engineering, and working with everyone's got like their favorite cloud provider or hardware vendor, and so it's pretty amazing how they work and do open up in a way how they're doing business and how they're managing and implementing technology.
I mean, I've been told since I was a little girl that Red Hat products and Linux are one of the most stable operating systems in the entire world. A lot more than the other guys. So, I mean, it wouldn't surprise me if that's still very true because of it's open source, and so everyone contributes.
Right.
And it's the culture around it.
Right, and what's interesting though is that IBM acquired Red Hat almost 2 years ago, and everyone's kind of like, oh, IBM, it's but they really want to adopt Red Hat's ethos and incorporate where they can, whether it's in the products or whether it's with customers. So and with most of my interactions with IBM folks, though we don't, it's kind of like we're fairly autonomous, right? We work independently. We work with IBM. They pull us in when they can, and when it's the best for the customer. But you can tell there is an enthusiasm from IBM to be able to take some of what's going on, and even Microsoft for that matter. I mean, we're big partners with Microsoft, again, another well-known proprietary technology company, but there is so much partnering going on. So And I think they realize that, at the infrastructure level, that's not, it's been commoditized for the most part. It's really getting the solutions out, the business solutions, the integrated solutions, and not just the under the cover stuff they're going to make money on at the end of the day.
So do you have any closing thoughts that you'd like to share or recap on?
Oh, I mean, I love my job. I love being able, I love working with the customers. Mm-hmm. So, I miss working with Department of Energy customers in the scientific and research. I love to work with the healthcare customers. And now I work with state, local, and education customers. And, you see them day in and day out. They're they're living their lives. They have, and the last thing you want them to do is be burdened with all these, complex technology decisions and supporting it and maintaining it. So I really enjoy kind of helping them out in that way. In a sense, being truly a trusted advisor or consultative. Not just I'm not just some sales guy slinging some particular. You got to buy these, you got to buy that. Now, obviously, I'm paid to have an opinion, right?
Yeah.
But I don't mind sharing what other things are, like like Terraform, for instance, which is a great technology, and a lot of stuff that Microsoft and Azure is doing. So I at the end of the day, I want my customer to be successful because I want them to have a life as well, right? Because we do live the work and not live. I'm sorry, did I say it right? We are working to live and not living to work. And so that's what I kind of want to see that in my customers as well as myself.
Well, it sounds like you're very passionate and very skilled with all the work that you're doing.
Well, thank you.
So congratulations,
thanks,
I think.
Thanks.
And thank you for coming on Sarah in Tech and
yes,
talking.
Yes, it's been an honor and a pleasure.
Well, thanks.
So, thank you very much. Take care.
Thanks for listening to Sarah in Tech. Feel free to email me at sarah@sarahintech.net or follow me on Instagram @sarahintech. Hope you enjoyed listening.